Thank you for both of your talks and your introductions. And obviously these are examples of DGFI funded projects, and you can see that there's quite a wide variety just in the presentations that you've had. And I will open up, some of you may have questions for the presenters, but I'll just open up with a couple of questions. And my first question is to Dr. Hua. The framework that you're using is very centered around kind of engineers and kind of graduates. How do you see that particular framework being spread across things like trades, for example, like electricians and that type of thing? I know you had some case studies that really, for me, brought out the advantage of what you're looking at. And you mentioned mechanics, and I'm thinking, what other kind of trades have you looked at, or you will be able to look at?
Yes, so we are looking at the skill-based indexing in this PACE project. So basically, we want the audience or users of PACE to understand that titles or what they learn is not limited to that particular term. For example, if you're studying a Bachelor of Electrical Engineering, what you learn is not limited to electrical, but also you will learn the skills, communication, project management, all these skills that is required, but not explicitly mentioned in your degree or the name of the program. So what we want the users or PACE to inform is that there are clear pathways for you to use your skills. For example, if you are studying a program that is not STEM related, you can always find a proper way to leverage your skill sets in this area. And for example, the case studies that we did, or the example that we mentioned in the presentation, is also to inform people that they can always find an alignment between what they are doing and what do we need in the clean energy, because clean energy is a so broad concept that we can involve a lot of people in this talent pool. And when we do the investigations of job roles, we also find some roles that we didn't realize before for the clean energy transition. So I would say skill-based approach would be something, make it more explicit so people can see, okay, so these are the skills that is needed for this wind farm, instead of like, these are the job positions available for this wind farm development. So it is more explicit, I would say, and it makes it more engaging for these non-clean energy employees to think about their careers in the future.
Great, thank you for that. Hamish and Angela, you've done a fantastic job of getting student energy off the ground, and such an immense amount of work that you've all put in. And Angela, we were both at the expo down at Canberra. We gave a delightful and moving discussion about how you grew up and how you came to be doing finance and how you're now doing student energy, which was really lovely. Thinking about what the future might hold for student energy, how can the DGFI and the university help sustain student energy in this new chapter?
Just going to test if this works. Okay, great. So yes, I think student energy, we've only just been around for 10 weeks, but we've already seen exponential growth from students, and how from all different backgrounds, there are individuals who are wanting to be involved and wanting to actually see, first of all, the skills that they have in finance or accounting or economics, how that is translatable and transferable to the energy transition. And so even just from leveraging stakeholders such as DGFI and industry stakeholders to talk to expertise and talk to people who are already within these clean energy careers and hearing their stories and seeing their day-to-day life and how they actually apply these skills into the real world, that's quite empowering for students like myself. And that was tangibly seen at our Illuminate event, where all of the students really took quite a lot away from asking questions and tangibly seeing like themselves in the shoes of these people already succeeding in the role. And that common thread there is like problem solving, analysis skills, adaptability, skills which reside in every single career pathway. And so I think for student energy, the plans that we have in terms of moving forward next year is to tap into a more broader student base and really show them that this is a universal problem. Like Hamish said, it's not just an engineering problem, it's a societal problem, it's an economic problem, it's an environmental problem, and that people of all different skills and backgrounds have that capability to drive change in that space.
Fantastic answer, thank you. Hamish, you're a chemistry student, I gather.
Yep.
It's good. My youngest daughter is just finishing a chemistry degree at Sydney, and she has brought home to me some of the really interesting things to do with quantum engineering, and little did I know how big a part chemistry actually plays in that. So from your point of view as a chemistry student, what do you see as the future being in terms of how chemistry can play a part in the energy transition of the future?
That's a really good question. So I've been very fortunate to study chemistry as well as renewable energy engineering. So I've got a bit of a more broad kind of understanding of the entire industry and how chemistry can play a part. For me, the things that I've seen the most is actually new technologies. So we always hear about, these are the engineering problems, but a lot of the solutions, such as grid-scale batteries, such as renewable biofuels, these are things that the School of Chemistry are developing on the side at the moment. I think that's a really important thing that chemists are doing. Maybe a problem, especially in university context, that I've already seen is that there is a bit of segmentation. This is the School of Chemistry, this is the School of Engineering. And I think a lot of the work that's being done could be a lot more maybe productive and go a lot further if there was a lot of collaboration between these schools.
That's a great answer and leads me on to a kind of question to all three of you, although we don't have a lot of time, so I'll ask you to be brief. Do you think, Hamish, that talks to the notion of having a kind of decarbonisation degree that kind of cross-cuts all the faculties?
Yeah, I think even just courses. I think one of the problems in a university context in terms of learning for a rapidly developing industry is a lot of the content that you're taught is just, this is what it is. It's like high school maths, something that everyone comes out of it at some point saying, why is this important? I don't understand. So having courses where you can go, finance students, you study this is directly how it's linked to jobs. Engineering students, you've learned all these concepts, these are the projects that you can use your skills on. I think those kind of courses and in that kind of decarbonisation degree that you mentioned would be something that provides a lot of value and shows students really clearly how the link between what they're learning and what they're doing and the jobs that they want to be a part of.
Angela, do you have any comments from your perspective as a kind of finance student, amongst other things?
I completely agree with what Hamish has said there. But in particular, I wanted to echo that in our separate degrees, we're sort of trapped in those silos as to if you study finance, these are the conventional pathways that are expected of you, whereas that's completely not the case at all. And when I was a first year student, being taught accounting or like management accounting, for example, you get sort of put into these bubbles. But yet again, I felt like I had to compromise between my personal interests of sustainability and then choosing what was feasible or like what would be good for me in terms of my career pathway. And so what I think UNSW and just academics can do altogether is just to integrate more, I guess, interdisciplinary and transferable projects into these courses themselves. It doesn't have to be at a degree level, but even just within a classroom. For business students, it could be case competitions, which I myself am quite fond of. For law students, it could be negotiation competitions. For comp sci students, it could be hackathons, or blended with sustainability and clean energy. That would be, I think, an excellent way to show these students at a young age, like how this is an issue which permeates across all fields, not just engineering.
And Dr. Hua, I know that you've had some involvement in micro-credentials and the development of those courses. What advice would you give to the university in terms of how it could do a better job of that type of thing?
Yeah, so I think Hamish raised a really good point that the boundary between different schools and disciplines that we probably have, not only at UNSW, but not most of the universities, they are running courses individually instead of collaborating. So currently I'm working on a hydrogen microcredential, and the work we have done is to collaborate with the School of Energy Resources and Mineral, with expert in hydrogen energy production to co-design the course with the expertise in chemical and resource and energy generation as well as electrical, because we want to make sure that the content are aligned with the industry expectations and demands. So we want to make sure it is technically correct in both electrical and chemical aspects. Also for what they mentioned in terms of the content, for example, the math, for example, the financial courses. What I did in the past, because I used to teach like first year electrical engineering courses. So I think contextualize problems and projects for the student would be helpful for them to understand what are the application of their knowledge they learned. For example, in first year large circuit analysis courses, we introduce solar powered pad house to the student, although they don't really know what is the model of a solar panel, but they can align a solar panel with the voltage and current source they are learning in the course. So it is a simplified model, but they get exposure to these concepts very early at the university study so that they can be intrigued, they can get the idea about what they have learned in the real world application. Also, for example, Thevenin equivalent circuit. So in the exam questions in the textbook, they always see a very boring circuit with voltage sources and lines and resistors. But what we can tell the student is that in a power system, a fault happens in a transmission line. We just use these circuit analytical techniques to solve these problems, to calculate the fault current. And then even the student don't have the capability to do these calculations at the moment, but then they align what they learned with the real world application, and they know, okay, so this is how I can use what I learned into my future probably career as an electrical engineer. So I would say university needs to think of how to design more contextualized content, especially for early year students, so that they can find what they learned is interesting first, and then useful as well in their future career.
Great, thank you. And I'm getting a look from Sharon that's telling me time's up. Thank you to all three of you for... Oh, sorry, yes. I did promise questions.
We do have a very special guest who's actually being live streamed at the moment.
Okay.
Peter Tyree, who does have a question. So,
Okay.
Peter, if you can hear me, unmute yourself.
Okay, in the meantime, maybe I'll take a question from the floor if there is one. Gavin.
Thanks, John. Thank you very much. Gavin Conybeare, School of Photovoltaics and Renewable Energy Engineering. Fascinating topics, great work. I really like both your student activities there, which are very interesting, and also the mapping of these different mechanisms for training engineers, and not just engineers, but the whole range of people we need for the energy transition. So I wanted to ask about that, about the broad range of topics that we need to teach. We need to go all the way from school children, from K to 12, transitioning engineers who are already doing engineering degrees, pathways for graduates, but also transitioning engineers and other professionals from other spheres. But on the one of the things I wonder about that is how can we integrate all those together into finding the right mix of professionals that we need and educating them in such a way that we can actually put them all together to have the energy transition. And does that have to be done in a top-down sort of way, or is it something that can happen in an organic way with these pathways available for feeding in the professionals needed at various times to fill the gaps that we need in these areas? But what I'm saying really is, how can we match together the various different pathways in such a way that we get the, I'm trying not to say engineers all the time because I'm aware of the fact that we need more than just engineers, but there is a big shortage of engineers, so that's one of the primary areas. So how can we ensure that we do get the engineers by these various pathways? For instance, the school-age children are an essential route for the pipeline for getting students coming up through, but they're going to be longer term. It's going to be a minimum of 4 years, up to 16 years for students coming through in kindy at the moment. Although actually on that point, there is a big problem with young primary school students losing interest in maths and other technical subjects at a very early age, and then not getting back into them again. And one of the problems there is that there's also a shortage of teachers in STEM and in maths in particular, but also in STEM, and an interest in sort of driving students through in those areas. So, well, there's a whole lot of areas there. Perhaps I shouldn't talk about that too much, but what I really wanted to say is that we've got that pipeline of students coming through from schools, but then we also have the other pipelines from other areas, graduates and transitioning people from other disciplines, etc. How can we match all those together to give us the right mix of people that we need to have an energy transition?
I would say this.
There's a lot of questions in there and a lot of observations which are very useful. Maybe I can make an attempt at an answer, and I think it's partly we need to establish the whole ecosystem across, not just across engineering, not just across STEM. It's got to be STEM, non-STEM. We've got to think about all the different ages where we need to create a pipeline. And you know, these initiatives certainly play a part in establishing those, but it's a huge effort, and it takes many of these things to happen in many different places. I don't know if any of you got any other observations you'd like to make on that particular question.
I think the only thing that I would add is that I think the important bit is just seeing, like for children, being able to see that, oh, that's an option. I think that's something that isn't very clear at the moment. Like very stereotypically, if you think of a lawyer, you think of a criminal lawyer, you don't think of a contract lawyer working in power price agreements for renewable energy plants. There are a lot of different ways that these skills and these careers have really important applications for the future of energy and being sustainable. But if you don't think that it's an option, you can't get a kid to have that, think that that's a career that they can even do. That's what I'd say.
It's Peter Tyree here. What a great job you've all done. I had a few thoughts as you went through, and I want to pick up on the issue of mechanic picking up a car or whatever it is. If I'm a little bit rude to suggest that if we say that the role of an engineer designing a new grid that's one of the most complex machines, you can put your hand down now. Designing one of the most complex machines that's far more complicated than a motor car or an excavator. And if we've got a skill set shortage there, we must have a massive worse problem to up getting trained, experienced engineers and other people to design and build one of the most complex grids in the world. AI may play a major part in trying to develop a lot of the skills which the panel has been talking about. The skills that are going to be maybe more of a problem are those of the trade, build the transmission lines and to install the distributed generation. There may be tens of millions of generators to be built. There'll be many, many thousands of kilometres of grid to be built. And the technical side, which may well fit under artificial intelligence type applications, but who's going to feed in all of the engineering know-how? Is now most people like myself that have been in the electricity industry for many, many years are getting a little bit past it, and we'll all be dying off before long. So how do we get all of that skill put into the future engineers that are growing today?
Okay, I think I'll try and paraphrase that. I think the question is really about how do we ensure that we have a continuity of engineering capability, whilst I guess using AI as much as we can, but without also losing that kind of human part of engineering. And it feels a bit more like an observation than a specific question. So I'll maybe take that as a note, Peter. And if you want me to put that question again, maybe you can send us it in a message, and we'll ask the audience later on in the program. And my apologies that we couldn't hear all of your question.